All right, we're going to talk about gravitational potential energy. I think this is section 13.5. It's if you recall the change in potential energy, U final minus U initial is equal to the change in its work. The work is F times the force times the distance. So the change in delta U is equal to minus the integral from R initial to R final of FR dr. So, well, FR, the force, is a function of it's an inverse squared relationship. So FR is equal to minus G, the gravitational constant, times the mass of the Earth times the mass of the object that we're looking at, divided by the radius squared. And if we look at that, the GME M, that's a constant, so we can pull that out of the integral, and we get the delta U is equal to the GM G, mass of the Earth, mass of the object, times the integral from R initial to R final of dr squared, where the integral of 1 over R squared is minus 1 over R. So we come up with GM of the Earth times M times the minus 1 over R evaluated from R initial to R final. So we get our last line, the change in potential energy is minus G MEM times 1 over R final minus 1 over R initial. So this only accounts for a radius that's greater than or equal to the radius of the Earth. You can see how this falls off here, and the limit here is the radius of the Earth. So the potential energy, and we have a minus to show that if R increases, it goes to 0. So the potential energy goes to 0 as R approaches infinity. And so the gravitational potential energy is equal to minus GMEM divided by R. Now, this is not an inverse squared law. It's only an inverse to R. So it's inversely proportional to R. So, and it holds for any two masses. It doesn't have to be the mass of the Earth. The gravitational potential energy is equal to minus G M1 M2 over R. And so if we have a system of 3 particles, 1, 2, and 3 divided by R12, R23, and R13, it's just a summation. You have the total potential energy, potential energy of 1 to 2, plus the potential energy of 1 to 3, plus the potential energy of 2 to 3. And it's just using the distributive law, we pull out the G minus G times M1, M2 divided by R12, plus M1, M3 divided by R13, plus M2, M3 divided by R23. And I think that's all for this particular section. We'll go on to, I think it's 13.6 next. Oops.